Okay, so what we're going to look at now is the finance application of our arithmetic sequence, and more importantly, writing them in a recurrence relations scenario. So this is where you're going to go into year 12. You are going to learn finance, and the way they they use the formulas and explain all the different scenarios is by using recursion. So you can see the first one we're going to use or look at is simple interest. Now, simple interest is an arithmetic sequence. So what does arithmetic mean? It means you were either, remember, it was either you were adding or subtracting the same amount. So with simple interest, and you might want to put a little note there. So with simple interest, you're always adding the same amount. So simple interest is you're adding the same amount of interest, what it is. So the interest is money earned, each time. So what happens, like you have a certain amount of money, you're going to get, they're going to say, we'll give you a percentage of that as interest. So you'll work out the percentage. Say you had $100 and they said, we're going to give you 10% simple interest, and we'll give it to you every year. We'll give you 10%. So 10% of $100 is $10. So every year, $10 is getting added on. So can you see how that's an arithmetic sequence? You started with 100. So 100 was your, like we're now going to call it VO. And then you're going to add this interest. So the $10 every year is like that D, the common difference, okay? So you might need to, so why I'm putting the formulas in this table sort of form for you is because you're going to have at the end a whole summary. I'll have a summary sheet that just has all the formulas all together. And you'll use this again next year. So the more you get used to this, the easier it's going to be for you because you're just so familiar with it. All right, so here's simple interest. So when they say the initial amount, the starting amount, when we talk about finance, they call that the principal. So you might need to write in here, this is the starting amount, or if you want to say the initial amount. Okay, so that's what VO is. So they'll use the word principal. Sometimes they say they might not, but if they do, that's what they mean. So if you have a look at this table here, you can see you've got columns. So in this first one here, you'll see it will give you the recurrence relation, so the basic setup for simple interest in a recurrence relation. So what you would do is you'd state the VO. So in my case, I said $100, and then you'll state the rule on how how this interest is being added. So in that case I talked about, I would write the rule as VN plus $10. That's what every time we're going to add $10. All right. So how did I work out that the common difference for this scenario? So when you have simple interest, it's a percentage of the original amount. So it's a little bit hard to see you can see it on your paper, but that's R. So when I said, all right, we're going to give you 10% simple interest, that was like I'm going to say 10 over 100 times the $100. So that's how you can work it out. All right, so this is, sorry, it's a bit blurry up there, but it's clear on your paper. All right, so let's go. Now, this middle column, it shows you the nth term formula. Because what happened if I said, all right, tell me how much your investment is. So say you invested $100. Tell me, how much you are at after 25 years, just say for example. So you don't want to keep on adding it on from the start. So we'll use that nth term formula. And here's how we can work that out, with VO being your original amount and D being the difference and things like that. This will make a lot more sense once we do some. So let's have a look at these examples here. So an investment of $3,500. So get into the habit of putting what that is. That's VO. That's your original thing. So put that there. Now, it has an interest rate of 4.25% per annum. Per annum, does anyone know what that means? Yeah, every year. So they're going to just give you 4.2% every year. So what you need to do for this, we indicate the per annum rate with a little r. So they've told me what little r is, and they will have to always tell you what type of financial scenario we're talking about. And this is the key. They're always going to have to tell you it's either simple interest, we'll do some others where it's compound. So you can know exactly what you're doing, and you can go straight to your formula sheet and know I'm using simple interest, okay? So it said find the amount of interest paid each year. So if you look up the top here, we can see that D equals the amount of interest. Okay, so we're looking at our formula sheet and we've said, okay, so D is the amount of interest paid each year. And then if you look, I write out what is the formula for D. It's R over 100 times VO. So if I go into this scenario, I would go D equals, now the rate is 4.2 over 100 times VO, which was 3,500. So we end up with, what was that one? 147, good. So 147, okay? So if I know it hasn't asked you here, but we're gonna do a little bit on the side here, just to show you. If I had to write the recurrence relation for this scenario, what I would be writing is I'd write VO, and it was actually 3,500, and then I'd have to write the rule, Vn plus 1 equals Vn, now see up in my formula sheet, if it's highlighted, it means you have to change that to a number. So we know what D was, it's 147. So if you were asked to write the recurrence relation for that, that's how you would do it. If I was asked to write the rule for the nth term, okay, so if I was asked to write the rule for the nth term, I would write Vn equals, now I have to write, I'm looking at this formula in the middle, I'd have to write VO, so in this case is 3,500 plus N times D, which was, 147, okay? So there's a rule, the nth term rule. If I got asked to write that, or then I might get asked to write that, and then I might get asked to find, after 13 years, just use that one. Okay, we'll do more practice, but I just want you to have it in your notes right there so you can sort of understand when you're looking at it. All right, let's do this next example down here. It says an investment of 4,600, so that's a VO. So when they say investment, that's like your original. That's what you're going to give a bank, and they're going to pay you interest. Now, they say a rate of 5.1 per annum, so that's telling me R. And once again, they're always going to tell you, so I know which formula to use, they will have to tell you. So we're going to simple interest. Now it says find out the amount of interest. So we know that's the D value. So write out the formula. And then, I'll just do it here. So it's 5.1 divided by 100 times 4,600. So if you do that on your calculator, you get 234.60. Now, you're going to see me always rounding now to 2 decimal places. Why would I always be rounding to 2 decimal places? Yeah, because we're talking about dollars, and cents is our lowest value. So you will automatically need to know that, yeah? So round to 2 decimal places because we're talking about money, So just maybe put that in there so you remember. Okay, the following recurrence relation can be used to model a simple interest investment of 2,000. So you can see that they've put the VO, so that's the initial, and the interest rate is 7.5%. So what they did here, if we just want to have a look, this bit here, okay, that was your D, that's the D value. And the way they found the D value was they did R over 100 times VO. So when they did 7.5 divided by 100 times 2,000, that's how they found, that's why they've got 150, because that equals 150, okay? Just so you're aware of where they found that. Why is that sitting there like that? So, and then obviously, they just showed you that down there. Okay, so now when the question, it says use the recurrence relation to find the investment after 1, 2, and 3 years. So it's very important, because they've said use that relation, we have to show all the steps. Remember, even though it's very basic, like arithmetic, you still have to show it. So what I need to do here is I have to write V1. And V1 equaled, well, what it was is the one before plus 150. So we're going to see 2,000 plus 150 would equal 150. Then I have to show that V2 is the one before. So you can just write the one before plus 150. So we get 2,300. And then we're going to write V3. And we're going to say 2,300 plus 150 equals 2,450. So that is the only way you are going to get the marks for that A, okay? It would probably be a mark. Maybe here might be 2 marks, but you're only going to get it if you show that working out like that. So someone just said, do you need to put in dollars? No, because we've just got the investment. You can just keep that number like that is. So you can write it like that. That's fine in a recurrence relation. Okay. Okay, so then B, it says, when will this investment reach 2,750? Now you can do this recursively on your calculator. So remember when I said you pop the first one in, press enter, then you go add a 50, press enter, and you can just keep clicking enter, and because you're pretty close to 2,750, and you will find at V5 we get 2,750. So your answer is going to be after 5 years. Okay, the following recurrence relation can be used to model a simple interest investment of 3,000. So you need to underline that it's simple interest. I know we're doing simple interest as everything now, but when you get your exam and it's all mixed up, you need to know which one it is. Okay, paying an interest rate of 5.2 per annum, so that's my R. And then they've given me the recurrence relation, that's okay. And then it says, use the recurrence relation to find the value of the investment after 1, 2, and 3 years. So let's just do it. So V1 would equal the one before plus 156. So that equals 3,156. Then show that V2 is the one before plus 156, which equals 3,000, what's that, 312? Is that correct? Yeah. And then V3 equals that plus 156, which is going to be, what's that, 3,468. Okay, so when will the investment hit 4,092? Now, you could keep on going, but I'm going to show you how we can find that using the nth term. So I'm going to use the nth term simple interest formula. And what I'm going to do is, so I'll write that out. So if you look, it was Vn equals VO plus N times D. So in this example, it would be 3,000, because that's what VO, plus N times, and I can see the D in that recurrence relation up there, so times 156. So what we want to know is when will the value be 4,092? So what you want is when will this value equal that? And obviously we want to know N, how many times. What do you think we could do here? Yes, awesome. Someone said it. So let's go solve, comma N, and let's work that one out on our... Okay, so N ended up being 7. So for the answer of this one, we could say, when will the investment? We'll say after 7 years. Okay? Let's do this one. So the following recurrence relation can be used to model simple interest of an investment paying 12,000. So there's VO at 4.8. So there's my R. Now, it says the first question is, how much interest is added to the investment each year? Now, you don't have to calculate the D, because that is the D, but why don't I have to calculate it? Can I see it? Yeah, it's there. What is it? Yeah, so this is how they found it, just so you can see, but we'll just pop the calculation in so you can see how they did that. And that ended up being 576. But you could have simply read the recurrence relation, and that's okay. That means you understand that. So then the next question, B, use the rule to find the value of the investment after 10 years. Now, when you see that, when they say use rule, yeah, and we want the nth term rule. So we want the nth term rule. Nth term for simple interest. So you would go to your little summary table and you're going to see that it's Vn equals VO plus N times D. So in our scenario here, it's going to be Vn equals 12,000 plus N times, 576. Okay, so we want to find... What we're actually trying to find is V10. So when you're finding V10, what you want, every time you see an N, you'll put a 10 instead. Okay? So then you'll end up with...
Can you still do solve for that though?
No, so you don't really need solve for this one, because all you have to do is put that into the calculator. Yeah? And so we'll get 17,760. Okay, so now it says use the rule to find when the value of the investment exceeds 20,000. So this is our rule. We're going to use that rule again, but we want to know when it equals 20,000. So what we're finding is 20,000 equals the rule. Oops, sorry. And obviously we want to know a time period. So you're going to pop in solve there. So the reason I put solve in purple, you don't need to write that on your paper in year 12. Don't write the solve, just write the statement in black. And then what you do is then write what n equals, okay? So don't write the solve, but this is on your paper so you know to use it. You know, you go use your calculator. So let's go do that one. Okay, so when I do that, I get 13 point, I'm going to say just round, 13.9. So that's 13.9 years. Now, you must, for this, you should always go up. So I'm going to say this, we're going to always round up. And it doesn't matter even if it was 13.1. Why is that? Because if you did 13, if it was 13.1 and you went to 13, it means you're not going to be over it. Yes? So you always got to be over it. So once you've hit a number, see, so 13.9, we're going to say, it says to find when does the investment first exceed, you're going to say after 14 years, yeah? So write all this, so then we'll just say, so the answer, it exceeds 20,000 after 14 years. All right, one more, last one. The following recurrence relation can be used to model simple interest of 4,000, paying an interest rate of 6.5% per annum. So how much, we won't do all the working out, we're just going to read. So how much interest is paid each year? Let's just read the recurrence relation. How much is paid? 260, good. Because they didn't say how many dollars, normally in your VCE exams they put it in there, so let's just put $1 because they haven't put it in the question. Use the rule to find the value of the investment after 10 years. So we're going to use the nth term formula, which I'm just writing out our basic one. Okay, so in this scenario, VN will be 4,000 plus n times 260, okay? And they want us to find V15. So it'll be 4,000 plus 15 times 260. So in your calculator, you just have to type that little equation there. And what do we get if we do that? 4,000 plus 260 times 15. We get 7,900. That's what V15 is. And then part C, it says use the rule to find when it first exceeds 10,000. So we're going to write 10,000 equals our nth term formula, which we've already worked out. Okay, so remember you can write that out, and then what we're actually going to do on the calc is use solve. But remember, don't write that on your exam paper. Just write what's in the black and solve it and write n equals. Okay, so we got 23 point, I'm going to say 1. So what are we going to say?
23.1 years.
No, let's just go to the nearest year, which would then be after
23 years.
to 24. What do we always have to do?
Round up.
Round up.
Bro, yours is